This is Algebra with Finance A, Unit 2, Lesson 4, Measures of Variation. So far we've been finding the measures of center, the mean, the median, the mode. These are all measures of where the center or where the dominant value of a set of data is. But now what we're going to measure is spread, how spread out the numbers are. And there are several different kinds of measures that we can do. We can find the range. That's the simplest. We can find the interquartile range, the IQR. We can find the variance. And we can find the standard deviation. Okay, we're going to examine each of these. Now, for the sake of calculation, I'm going to keep the list of numbers fairly short. I'm just going to deal with, let's work with 5 numbers, right? So let's say we've got 5 test scores, all right? And these are my X sub i's here, my test scores here. So they are 97, 84, 80, 62, and 54. Okay, there we are. All right. And let's find first the range. The range is the biggest. Okay, biggest minus the smallest. So in this case, the range is 97 minus 54, or looks like 43. Okay, so the range, the bigger the range, the more spread out the numbers are. The smaller the range, the less spread out the numbers are. But let's say I changed one value, and I changed the 54 to 2. Okay, that would have, changing that one number would have a very large impact on the range, wouldn't it? 97 minus 2, and now it has a range of 95. When all I did was change a single number. Okay, that's called an outlier, by the way. And so range is very much impacted by outliers. Interquartile range might be a way to overcome that. Basically, what you do is you find the first and the third quartile. So it's quartile 3 minus quartile 1. Okay, so the way we find the quartiles, we find the median. Halfway between 84 and 80 is 82. And then we find the middle of the upper half, halfway between 97 and 84. Let's see, 97, 84, that's a difference of 13. 13 divided by 2 is 6.5. So 90.5, because we add 6.5 to 84. Okay? And actually, whoops, I just realized something. I did something wrong. There's a 2. So the median is 80. The median is 80. Okay, and the quartile is still 90.5. Okay, the quartile here, 62 and 2. The easiest way here is just add 64 divided by 3 is 30. 30 divided by 2 is 31. Okay, so that's quartile 1, and our quartile 3 actually, and this is quartile 1. In which case, the quartiles, the difference between the quartiles is really quite simple. Okay, it is, what we say, I forgot what it was already, 90.5 minus 31. Okay, and notice this is not impacted by the 2, right, by that outlier. 90.5 take away 31 is basically 60, take away 0.5, 59.5. Okay, now variance is a little harder to calculate. There's a formula for that. Okay, x bar squared is the symbol. You take each of the items, each of the numbers, the x sub i's, and you subtract the mean, the average. Then you square that difference. Then you average those. So you divide by how many there are. So this is a series of steps. Find the mean. Subtract the mean from each x value, square that, and then average that. Okay, so let's do that. Let's change colors here. Purple will do. All right, so I'm going to add them up. 97 and 84 is 170, 181, 261, 323, 325. 325 divided by 5 goes 5 times 6 is 30, 5 times 5 is 25. So 65 is the mean, right? So now we're going to do the x sub I minus the x bar, right? 97 minus 65. Minus 65, minus 65, minus 65, minus 65, minus 65. Equals, 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 equals. Okay, so 97 minus 65 is 32. 84 minus 65 is 20, but less 1, so 19. 80 minus 65 is 15. 62 minus 65 is negative 3. And then 2 minus 65 is negative 63. Okay, and now we're going to square that, right? So we're going to take those differences, this is the x sub I minus the x bar, and we're going to square them. Okay, these don't equal, so I'm not writing an equal sign. This is just the result of squaring. 32 squared, I have no idea. All right, Desmos. Oh, calculator. And you can use a calculator for all these steps. But it is important that you know how to find the standard deviation. I will show you the way to calculate it straight off as well. So 32 squared is 1024. Of course, it's 10 to the 2 to the 10th. 1024, I should have known that. 19 squared, I should have memorized, but I haven't. 19 squared, 361. 15 squared, 225. 3 squared. Negative times negative is positive, so you notice all the negatives are gone. 63 squared. 63 squared. Okay, 3969. 3969. Okay, and now we do the average of these, right? So we take each x value, subtract the mean, square it, and then average them. This means sum. Add them all up. Add them all up and divide by how many there are. So we're going to add these up, and that's not going to do that in my head. 1024 plus 361 plus 225 plus 9 plus 3969, 5588. And we'll find out if we made any mistakes here, by the way, 5588. And we divide by 5. 5588 divided by 5. 1117.6. So 1117.6. 1117.6. Okay, so that's called the variance. Now the variance is a measure of the spread, but you notice it's really big. Okay, really big. And what on earth does that mean? So you may notice that we squared things, and when you square numbers, they have a tendency to get really large, especially if you're squaring a number bigger than 1, right? Well, squaring large numbers makes really large numbers. And so this tends to be really big. Let's undo that squaring, and the undo or opposite of squaring is the square root. So with x bar, I'm using the wrong symbol. X bars mean, okay, and it should be the sigma, the Greek letter sigma. Sigma squared. And sigma not squared is the same formula, the sum of all the x sub i's minus the x bar squared divided by n square root. Square root. So now we're just going to take the square root of that number. Square root 1117.6. And we get 33.4. 33.4 to the nearest tenth. Okay, so what we say here is that the average spread is about 33.4 plus or minus, right? So the average, the mean is 65, give or take about 33.4. So this is now a measure of the spread known as the standard deviation. All right, let me show you in Desmos how to find the standard deviation straight off here. Okay, so first of all, I'm just going to make a list, and I'm going to type a capital L equals square bracket, and then I'm going to put in my numbers here, 97, 84, 80, and we're going to find out if we did it correctly here, if we didn't make any mistakes. I do not know if I made a mistake. It's entirely possible. And then standard deviation, STDev L. And it says 37.4. Oh. All right. Now, one thing actually, STDev and STDev population, or is STDev the standard deviation of the sample or the population? Functions, statistics. STDev P, careful here. STDev P, 33, there we are, 33.4. So we did it correctly. STDev P. The standard deviation you guys are finding is the standard deviation of the population. The standard deviation that many calculators give is called the standard deviation of the sample. Okay, population, standard deviation. And the sample, the standard deviation of the sample is different in just one thing. You still take the sum of the x sub i's minus the x bar squared, but you don't divide by n, you divide by n minus 1. Okay? So you divide by a slightly smaller number, making your answer a little bit bigger. Okay? So be aware the standard deviation is STDev P for population. That's the standard deviation we're going to use in this class, right? STDev P. All right, hopefully that helps.